The work order said Structural Resonance Support Technician, Auxiliary, which is the kind of job title that means you carry the heavy case and don't touch anything. I'd been assigned to the Vashral Grand Resonance Hall 9 days before the broadcast. The hall sat in the upper spoke of Cuvithtor Station, a neutral ground orbital about 40 minutes from the Keithril home system at standard transit, close enough that the Keithril considered it basically theirs, far enough that the station charter kept it officially non-aligned. The hall itself was the centerpiece of the whole complex, a performance and broadcast venue that seated 11,000 bodies across species lines, with a resonance array in the subfloor that could push synchronized acoustic output to relay networks covering a third of the inhabited systems in the sector. The night I arrived, it was being prepared for something called the Vashral Accord Commemoration Broadcast, a live galaxy-wide event marking the 100th cycle of a multi-species diplomatic agreement that had, apparently, kept several wars from starting. Significant occasion, the kind of thing that goes wrong at the worst possible time. The Keithril are tall, fine-boned, and have lateral hearing organs that run in a double row from their temples to their jaw, 4 pairs per individual, capable of parsing frequency ranges that most species can only measure instrumentally. They are, by any fair standard, extraordinary acoustic engineers. They have developed resonance architecture into something between a science and an art form over the course of about 800 years of serious study. Their credentialing system takes 12 years to complete. Their senior engineers have professional designations that take up 3 lines on a standard ID form. They explained all of this to me during orientation. The orientation lasted about 40 minutes, and the relevant part, the part concerning me specifically, was communicated by senior resonance architect Thelvon in the tone of someone explaining fire safety to a decorative plant. Your assignment file indicates a designation in human structural acoustics, he said. He had reviewed my file from a distance of about 2 meters, which I would later understand was standard Keithril professional courtesy, close enough to engage, far enough to signal assessment in progress. We've reviewed the qualification framework. It is a vibrational folklore tradition with some applied mechanical competency at low-frequency ranges. Not without value, as documentation of pre-lattice acoustic intuition. But you understand the array systems here operate on a lattice-integrated resonance architecture that has no analog in the human qualification tree. He waited. I think he expected me to argue. I understand, I said. Good, you'll be supporting resonance engineer Suvith in the equipment staging area, tool transport, calibration kit management, case handling. Happy to help, I said. He looked at me for a moment, all 4 pairs of lateral organs angled slightly forward, which I'd learned was a Keithril tell for mild uncertainty about a conversational partner, and then he nodded once and walked away. That was day 1. I want to be fair to Thelvon. The Keithril are not stupid, and they're not malicious. They genuinely have one of the most sophisticated resonance engineering traditions in the sector, and their lattice-integrated systems are, in fact, far beyond anything in the human technical qualification tree. When they looked at my credential file and saw Structural Acoustics Technician, Grade 3, Human Engineering Corps, 8 years field service, and then looked at their own 12-year credentialing path and their lattice calibration architecture, they made a rational inference. This human has some useful applied intuition at the folk level and should not be operating anything critical. The inference was wrong, but I understood how they got there. I carried the cases. I logged calibration kits in and out of storage. I kept the equipment bay organized and handed tools to Suvith when he called for them. Suvith was a junior engineer 8 years into his 12-year credential path, and he was polite in the way that very competent young professionals are polite to support staff, not unkind, not particularly interested. He told me what he needed and I provided it. We got along fine. What I did in the margins was listen. The Vastral array was a layered system. 22 resonance columns running floor to ceiling in the subfloor chamber beneath the main stage. Each column a stack of frequency emitters coordinated by a central lattice node that synchronized their output in real time. The combined effect, when calibrated correctly, was a standing wave pattern that filled the hall with precisely shaped acoustic space. Every seat in the house received the same tonal clarity regardless of position, and the broadcast output fed directly from the array into the relay network at a quality level that the Keithrel considered a matter of institutional pride. It was a beautiful system. I would not have known how to operate any part of the lattice integration layer. That part of the orientation had been accurate. But I'd spent 8 years working on resonance systems for human military facilities, bunker acoustic isolation, command center interference suppression, forward operating base communication dampening. Low tech, high stakes, do it with what you have because you're 3 days from the nearest depot work. You learn to hear things in that job. You learn that every system has a voice, and that the voice changes before the numbers do. By day 3, I could hear that column 14 was running about 2% low in its mid-range output. Not low enough to affect performance at current test levels. Not low enough to register as anomalous on the lattice monitoring panel, which was calibrated to flag deviations at 5% or greater. I mentioned it to Suvath on day 4, in the careful way you mention things when you're the person who carries the cases. Column 14, I said, while I was handing him a calibration tool he'd requested. Mid-range feels a little thin. Might be worth a close check. He took the tool, ran the lattice diagnostic on 14 and showed me the panel. All readings nominal, no deviation flagged. It's reading clean, he said, not unkindly. Right, I said. He went back to his work. I went back to the equipment bay. I noted it in my personal log, not the official maintenance record, which wasn't my document to write in, and I wrote down the date, the observation, and a rough estimate of the frequency range where the thinning seemed to live. I wrote it in a small spiral-bound notepad I'd had since my second deployment, which I kept in my left breast pocket because old habits are old habits. The notepad had been the subject of some curiosity on day 2, when Suvath had seen it and asked what it was. Notepad, I said. He had looked at it with the same expression Thelvan had used on my credential file, polite, diagnostic, mildly baffled. You're logging manually. Sometimes old habit. The lattice system maintains a full environmental record, every parameter continuous. I know, I just like having my own copy. He'd nodded slowly, in the way that people nod when they've decided something isn't worth pursuing further, and gone back to his console. The notepad stayed in my pocket. The 9 days between my arrival and the broadcast were organized, from the Keithrel perspective, into a precise countdown of calibration phases. Phase 1, full array baseline establishment. Phase 2, broadcast output pathway test. Phase 3, relay sync handshake with the 16 receiving stations in the sector network. Phase 4, final seal and lock, the array calibrated and held static until broadcast, with no further adjustment authorized unless a deviation exceeded the 5% monitoring threshold. Each phase went smoothly. The Keithrel engineers were, in their element, genuinely impressive to watch. Thelvan could walk the subfloor chamber and identify a 0.5% deviation in column output by the quality of the reflected sound alone. He didn't need the panel. The panel was for the record. Suvath could rewire a lattice node connection in the time it took me to get the right tool out of the case. Their calibration protocols were layered, cross-checked, and thorough. Phase 4 completed on the morning of broadcast day. Array locked. Engineers satisfied. Thelvan signed the certification document, and the chief station engineer, a species I hadn't met before, a Chorvalid named Dressen who had overall operational responsibility for the event, added the broadcast authority stamp. I carried the cases back to storage, logged everything, cleaned the equipment bay. Broadcast was scheduled for the 22:00 station time window. At 21:38, the array desynchronized. I was in the equipment bay when it happened. I heard it before any alarm sounded, a shift in the background resonance that the Keithrel would probably have described in technical frequency terms, but that I would describe as, the hall stopped humming the right note. There's a low-frequency standing wave you feel in the deck plates when the array is running in idle warm mode, a kind of patient, settled vibration like the whole subfloor is breathing slowly. At 21:38 it stuttered, not dramatically, not loudly, just a brief asymmetry, a hiccup, and then it resumed at the wrong depth, wrong fundamental, like a chord played with one finger lifted. The alarm came on 11 seconds later. I walked to the equipment bay door and looked out into the subfloor access corridor. Three things happened very quickly. First, every status light on the lattice monitoring panel changed from green to amber. Second, I heard Suvith's voice from the direction of the primary monitoring station, high, tight, professional but working to stay there. Third, I heard Thelvan come through the corridor at a pace that Keithrel engineers apparently achieve when circumstances override their customary precision, which is to say, fast. Which column? Thelvan said. The panel's showing distributed deviation, Suvith said. Not a single column. Sector B, columns 9 through 16. Deviation is reading at 4.8% and climbing. Lattice sync. Holding, the desync isn't in the sync layer. It's I'm running the diagnostic. I stood in the doorway of the equipment bay and watched them work. I did not offer anything. This was not false modesty. At this point, I genuinely did not yet know whether the thing I thought I was hearing matched what their instruments were showing, and I had no standing to insert myself into a diagnostic process conducted by engineers with 12-year credentials. I watched, and I listened, and I updated my mental map of the system against what the panel was displaying. 4.8% in columns 9 through 16, mid-range frequency band. Sector B, which was the left center array block, climbing. The panel ticked to 5.1. Red lights. The alarm's pitch changed. Dressen arrived from the stage-level access point with 2 additional Keithrel engineers I hadn't met senior, by the look of their designation badges, and the controlled panic that arrives with authority under pressure. Behind them came 2 members of the station's technical operations staff, both of a species I knew as Velthrani, both looking at the panel and then at the Keithrel engineers in the way that support staff look at specialists when things go wrong, waiting to be told what to do. Status, Dressen said. Thelvan delivered it crisply. Sector B desynchronization, cause not yet isolated, broadcast window in 19 minutes, array currently locked per Phase 4 protocol, deviation at 5.1 and holding. Holding was optimistic. It ticked to 5.3 while he was talking. What's the failure mode? One of the senior engineers' designation, Vithrin Call 3-line badge, asked. Unknown, Suvith said. Lattice sync is intact. Output pathway test was clean this morning. No mechanical anomaly logged. Environmental parameters within nominal. It's a calibration drift, the other senior engineer, Marath Sullen, said. He said it with the confidence of a man who has seen calibration drift before and knows what it looks like. Post-seal settling in the column substrate. It happens when the lock is applied during a minor thermal variance. Phase 4 lock was applied at 0940 with thermal variance at 0.003, Suvith said. Below threshold. Below logged threshold, Marath Sullen said. Logged threshold is accurate too. Run a full column substrate diagnostic, Thelvan said, cutting across both of them with the finality of seniority. All 22. Cross-reference against the Phase 4 baseline. I want the deviating substrate segments identified in 6 minutes. The diagnostics started. I watched the progress on the panel from the doorway, running my own parallel accounting in my head, or rather, running what I had in my notepad against what the panel was telling me now. Column 14, Day 4. Mid-range, 2% low below the monitoring threshold. Columns 9 through 16 now. Mid-range, climbing. The diagnostic finished in 4 minutes, 40 seconds. The results showed 11 substrate segments across the Sector B columns with minor variance readings, none individually above 2%, collectively compounding into the 5.3 deviation the panel was showing. Thelvan looked at the results, cross-referenced the Phase 4 baseline data, and was quiet for 20 seconds. "That's not drift," he said. "No," Mareth Sullen agreed, with the slightly smaller voice of a man revising his earlier confidence. "The variance pattern is distributed. It's not substrate settling. It's—" Thelvan stopped. He walked the length of the panel slowly, reading each column's readout in sequence. His lateral organs were fully extended, all 4 pairs, angled toward the columns in a posture I hadn't seen before. Assessment, I thought. Real assessment, not the professional courtesy version he'd pointed at me on day 1. 17 minutes to broadcast. Possible lattice relay fault between the sync node and the Sector B distribution block, Vithrin Call said. "Sync layer is clean," Suvath said. "Below the sync layer," Vithrin Call said, "in the physical relay pathway, a partial contact fault in the junction would produce exactly this distribution pattern. The sync signal is intact, but the relay is dropping a fraction of the carrier on the Sector B side." There was a brief silence during which everyone in the room understood that this was either correct and solvable or correct, and not solvable in 17 minutes. "Where's the junction?" Dressen asked. "Subfloor access point 7, Suvath said. He pulled the schematic on the secondary panel, behind column 14. I kept my expression neutral. "Can we pull the relay casing in 17 minutes? Thelvan asked. "Physically, yes," Suvath said. "But resealing the relay contact and allowing the lattice to restabilize takes a minimum of 35 minutes post-repair. We'd need to delay broadcast by 45 minutes minimum." Dressen looked at Thelvan. Thelvan looked at the panel. The panel ticked to 5.7. "A 45-minute delay on a galaxy-wide broadcast," Dressen said, in the tone of someone who is not saying what they are thinking, "is not an option I can authorize unilaterally." Thelvan did not say anything. He walked back to the column diagnostic readout and looked at the pattern again, the 11 distributed segments, the escalating deviation, the unmoving broadcast clock. "Is there a way to compensate at the sync layer?" Mareth Sullen asked. "If we know the relay is dropping carrier on Sector B, can we push compensating output from the sync node directly to offset the loss?" "We'd be driving a faulty circuit harder," Vithrin Call said, "to achieve broadcast quality output from the other 18 columns. It might hold for the duration. 40 minutes of broadcast. It might also drive the deviation into the fault threshold of the relay and take the whole Sector B block out mid-broadcast. Better than a 45-minute delay. Not significantly better." I had been in the doorway for 11 minutes. In those 11 minutes, 4 things had become clear to me. First, Vithrin Call's theory about the junction below column 14 was almost certainly correct. It matched what I'd heard on day 4, and it matched the distribution pattern on the panel, and it matched the location I'd noted in my log. Second, the Keithril engineers had correctly identified the fault but were working through the problem using the tool set they knew: lattice layer interventions, substrate diagnostics, relay contact resealing, sync node compensation. Third, none of those tools were going to solve this in 17 minutes. Fourth, and this was the part I'd been sitting with for about 6 of those 11 minutes, there was a different approach, and I knew how to do it. The question was how to say so. It is a delicate thing, being the person who carries the cases and having something useful to say. The dynamic is not hostile, the Keithril weren't hostile. But the credentialing architecture is real, and the professional hierarchy is real, and Thelvan had explained to me with genuine precision that human structural acoustics was vibrational folklore with some applied competency at low-frequency ranges. He had not been unkind. He had been accurate about everything except the conclusion. I caught Dressen's eye. The Chorvalid chief engineer was standing slightly to the side of the main diagnostic cluster, watching the Keithril engineers with the expression of a person who holds authority, but knows the limits of their own technical knowledge in a specialist situation. He was looking for something to authorize. "I might have something," I said. The room did not stop. This is the thing about saying something in a room full of people who are deeply focused on a problem. Unless you say it at volume, the room doesn't stop. I'd said it at a measured volume, not shouting, in the direction of Dressen, and Suvith heard it and looked up, and Dressen heard it and looked over, and then a half-second later Thelvan's lateral organs rotated toward me. "Corporal Anhand," Thelvan said, "the way you say a person's name when you are reminding yourself who they are." "The junction fault is real," I said. "Vithrine Call's read on the location is right, it's the relay carrier junction below column 14. I logged a mid-range anomaly in that column on day 4. Below your monitoring threshold, so it didn't show, but it was there." I paused. "The relay contact fault is mechanical. It's not a lattice problem. You're reading it as a lattice problem because that's what your monitoring architecture sees. But the relay casing has a physical contact plate, and the plate is either corroded or misaligned enough to be dropping carrier on the Sector B side." Thelvan was very still. "You're suggesting the fault is pre-seal." "I think so. I think it was already developing before Phase 4. "Why didn't the Phase 3 relacing test catch it?" "Because at test level output the carrier drop was below your threshold. The full broadcast load is pushing it past threshold. The lattice is clean, the problem is physical." The room was quiet for a moment. 14 minutes to broadcast. "Corporal," Thelvan said carefully, "you understand that the relay contact casing requires a minimum of 35 minutes to reseal after intervention." "I'm not suggesting resealing the casing," I said. Another pause. "What are you suggesting?" I held up the tool bag. "It is difficult to explain to someone who hasn't spent 8 years doing low-tech resonance work in places that don't have parts depots why a tuning fork is useful. I will try. A resonance relay contact fault, a physical, mechanical fault in the contact plate, produces a specific kind of signal degradation. The carrier signal doesn't drop uniformly. It drops asymmetrically, in a pattern that depends on which part of the contact surface is failing. The asymmetry has a signature, a ghost frequency, a secondary tone that appears in the output as a very faint out-of-phase component, below the level that most monitoring systems are calibrated to catch. You can hear it if you know what you're listening for. You can also feel it, in a certain class of relay housing, as a specific vibration pattern in the casing itself. The Vashral Array's relay housing was a type I'd seen before, not the Keithril design specifically, but the contact plate principle was shared with a class of military-grade resonance relay used in human bunker systems. Different materials, different lattice integration, same basic mechanical principle. 2 conductive plates in maintained physical contact, with the quality of contact determining the quality of carrier transmission. When a contact plate drifts, either through corrosion, thermal microexpansion, or physical settling, you can, in some cases, restore full contact temporarily by identifying the specific asymmetry of the drift and applying a compensating mechanical pressure at the right point on the housing. Not a repair, a stabilization. The equivalent of pressing a loose wire connector firmly back into its socket. It doesn't fix the underlying problem, but it restores function long enough to get through the immediate crisis. And then you do the proper repair when you have time. The trick is knowing where to press, and knowing that requires knowing the asymmetry pattern. And knowing the asymmetry pattern requires identifying the ghost frequency. You can do that with instruments. The Keithrel had very good instruments. The problem was that running the instrument protocol on that class of fault, identifying the ghost, mapping the asymmetry, and calculating the pressure point took, by Keithrel protocol, about 22 minutes for a lateral organ reader working with full lattice diagnostic support. I could do it in about 9 minutes with a tuning fork and a notepad. This is what I mean when I say that vibrational folklore has some applied competency at low-frequency ranges. Thelvan authorized it in about 40 seconds of very compressed decision-making that I suspect cost him something professionally. He looked at the panel, 14 minutes, and looked at the tool bag and looked at me and said, "What do you need?" "Access to subfloor point 7, the junction housing. Nothing else. I don't need the lattice panel, I don't need the diagnostic suite. Just the access hatch and a clear 2 meters around the column." "Suvith will open the access point," Thelvan said. I looked at Dressen. Dressen nodded a Chorvalid nod, which is a full-body forward tilt, and that was the authorization. Suvith opened the access hatch without speaking. He was operating, I thought, in the specific professional mode of a competent person who has been in a situation that their training hasn't covered and is filing it carefully for later review. He opened the hatch, stepped back, and held a station light for me without being asked. I took the tool bag and my notepad and went in. The subfloor access point 7 was a crawl space lateral, about 1.5 meters high, running along the back of the Sector B column row. Column 14 was at the far end. The junction housing was a gray-green rectangular casing about the size of a large suitcase, mounted at floor level behind the column base. Standard industrial mounting. 2 hexhead access panels, both closed. A manufacturer's data plate in script I couldn't read, and a small status indicator light that was blinking amber in the pattern the junction fault would produce. I set the tool bag down, opened it, and took out the tuning fork. 440HZ, the one I'd carried since my 3rd deployment, when a senior technician had told me that if you're going to carry one fork for everything, carry this one, because everything branches from this. I'd laughed at the time. I didn't anymore. I struck the fork against my knee, and held the base of it against the junction housing lightly, near the upper right corner of the casing. Felt it. The fork's vibration was partially absorbed by the casing, and what I could feel in the metal was the superposition, my 440HZ plus, whatever the housing was conducting from the relay system. I moved the fork base slowly across the upper face of the casing, listening with my fingertips, cross-referencing against what I could hear as the fork's audible ring changed character slightly against the housing's resonance. 3 minutes, notes in the pad. I moved to the side face of the casing, the Sector B carrier side. Same process. The asymmetry was there. I could feel the ghost in the conducting metal, a slightly flattened response in the lower right quadrant of the side face that told me the contact plate was losing surface in that corner. Physical settling, probably. The casing was warm to the touch, warmer than it should be, which confirmed partial resistance buildup at the contact, which confirmed the plate. 5 minutes 30 seconds, more notes. I put the fork away and took out the pressure tool, not an exotic instrument, just a calibrated compression driver about the size of a thick pen, the kind of tool that human resonance technicians have used in contact plate work since before lattice systems existed. I identified the compensation point, 17 centimeters from the lower right corner of the casing's rear face, where the mechanical geometry of the contact plate assembly put the optimal correction vector. I applied pressure. Not a lot of pressure, gentle, steady, angled correctly, about 40 seconds held firm. The amber status indicator on the junction housing stopped blinking. I held the pressure for another 30 seconds to let the contact settle, then released it slowly, watching the indicator. It stayed solid amber, not green, because I hadn't fixed the fault, only stabilized it, but solid. No blink. The contact was restored. I picked up the tool bag and my notepad and went back out. The panel, when I came back into the main subfloor space, had changed. The deviation readout was falling. Not fast, it was working its way back down through the lattice restabilization process, which takes a few minutes even after the root cause is resolved, but falling. 5.3 to 4.8 while I was watching. Suvith was at the panel, very still, watching the numbers. Thelvan was behind me in the access corridor. He had followed me back out. I hadn't heard him come in after me, but he'd been there. I found this out later. He told me he'd stood at the access hatch entrance and watched, which I think tells you something about what those 11 minutes cost him professionally and what he decided to do with that cost. "What did you do?" Suvith asked. "Contact plate on the junction was partially settled in the lower right corner," I said. "Applied corrective pressure at the compensation point. It'll hold for the broadcast window. After broadcast, you'll want to pull the casing and reseat the plate properly. It'll drift again within a few days otherwise." Suvith looked at the panel. 4.1. "How did you find the compensation point without the diagnostic suite?" I held up the tuning fork. He looked at it, then at the panel. 3.6. "That's a single-frequency resonance instrument," he said. "Yes. You mapped the fault with a single-frequency resonance instrument and a notepad." "And my fingers," I said, "the housing conducts." Suvith looked at the tuning fork for a long moment. He had the expression of a man who is doing a significant amount of mental revision in real time and is being very professional about it. 3.1, 2.7. At 21:54, the deviation readout reached 0.4 within the noise floor, and the panel went back to green. Amber status lights cycled out. The array's standing wave settled back into its correct fundamental, and I could feel the deck plates return to their patient, settled vibration. The hall breathing slowly again, the right note, the right depth. Broadcast window, 6 minutes away. Dressen said something in Chorvalid to his operations team that I didn't catch. One of the Velthrani station engineers started running the pre-broadcast checklist. The room organized itself back into functional mode, with the focused efficiency of people who have just averted something and know there's still a job to do. Thelvan came to stand beside me. He was quiet for a moment, watching the panel, and then he said, "You noted the column 14 anomaly on day 4. "Yes. It was below threshold. By about 3%, yes. And you logged it anyway." "I keep a log," I said. He was quiet again. His lateral organs were forward, not the professional assessment angle, something slightly different which I didn't have a translation for. "The method you used on the junction housing," he said. "The single-frequency instrument, the pressure point mapping." "It's a field technique," I said. "Pre-lattice. We still use it in environments where you can't run a full diagnostic suite." "Pre-lattice," he said. "Yes." He said nothing else for about 10 seconds, which in Keithral social rhythm is, I had learned, a significant pause. "Then I would like to see the notation method, the way you map the asymmetry from the fork output, at a convenient time after broadcast." "Sure," I said. He nodded, that same single, precise nod from day 1, and walked back toward the primary monitoring station to begin the broadcast window checks. I set the tuning fork on the corner of the calibration console next to Suvith station. Not on top of anything, not in the way. Just set it down in the way you set something down when you're done with it, and don't need to make a point about it. The broadcast opened on time at 22:00. I want to tell you what the broadcast looked like from the subfloor, because it's the part of this story that I think about most. From inside the maintenance access corridor, listening through the deck plates and the column housings, and the junction casing that had now been stabilized, and was carrying its full carrier load without complaint, what you could hear was something remarkable. Not the music exactly, not the way you'd hear it from a seat in the hall. What you could hear was the system working. The array's 22 columns in full synchronized output, pushing the standing wave through the hall in the precise pattern the Keithrel had spent 3 centuries refining. The frequency layers moving through the space in a structure so exact it had a quality that I can only describe as inevitable. Like hearing a very well-designed machine do what it was made to do. I'd been in the subfloor for other pre-broadcast tests. This was different. This was the broadcast itself, full load, full output, the relay network pulling from the array at broadcast quality, 11,000 seats above me full of representatives from species across the sector, listening to whatever the commemoration program had staged for the opening of the event. And the deck plates were giving me the array's vibration at 100%, the full picture, the foundation of everything the audience above me was hearing. It was 41 minutes long, the broadcast. I stayed in the subfloor for all of it, partly because there was nowhere else I was needed, and partly because I wanted to listen to the junction housing. It stayed solid. Status indicator light, steady amber the whole time. No blink. I took a few more notes. After broadcast, Dressen held a brief debrief in the operations room off the main corridor. Standard post-event process, everyone accounted for, system status logged, issues and resolutions documented. I sat in the back, in the same place I always sat with the tool bag. When Dressen got to the incident report section, he described the desynchronization event, the diagnostic process, and the resolution. He gave a factual account. In his description of the resolution, he named me and described the contact plate stabilization technique. He used the phrase field-developed analog fault isolation method, rather than the earlier terminology, which I thought was precise and not unkind. Thelvan was in the debrief. He added a note to the record. The Keithrel engineers maintained their own technical records separate from the operations log. That the pre-seal anomaly in column 14 had been identified by auxiliary personnel on day 4 and logged in a personal technical record, and that this early identification had been relevant to the resolution speed. He recommended that the monitoring threshold for Sector B columns be reviewed. Nobody said vibrational folklore in the debrief. Marath Sullen, I noticed, did not say much at all during the debrief, which was also a kind of statement. I stayed at Cuvithtor for another 6 days to complete the proper repair on the junction housing, the full pull, reseat, and reseal that would prevent the plate from drifting again. Suvith ran the repair, I assisted, and it was the first time in the assignment that I was working directly on a system component rather than carrying the case. We worked in a companionable silence for most of it. Suvith is a careful, methodical engineer, and I found working alongside him straightforward and easy. On the 3rd day of the repair, he asked me to explain the tuning fork mapping process in detail. I explained it. He listened with all the focused attention of a 12-year credential candidate who has discovered a gap in his curriculum. He asked good questions, technically precise, genuinely curious, no defensiveness in them. I answered each one as clearly as I could. On the 4th day, he asked if he could watch me demonstrate it on the now-removed casing, which was sitting on the workbench in the equipment bay. I demonstrated it. He watched, asked 3 follow-up questions, and then tried it himself with a fork I lent him. He got the asymmetry mapping right on his 2nd attempt. This takes considerably less time than the lattice diagnostic protocol, he said. It's also considerably less accurate, I said. The lattice diagnostic gives you precise numbers. This gives you good enough for field application. But good enough for field application was what the situation required. Yes. He handed the fork back to me, and stood looking at the casing for a moment. "I want to document the technique formally," he said, "for the technical record. If you're willing to help with that." "I'm willing," I said. "I'll need to understand the full notation method, the way you map the asymmetry in the subfloor." "I'll walk you through the notepad," I said. He looked at the notepad which was sitting on the workbench. "That notepad has been, you've had that since your second deployment." "Third," I said. "Second one got wet." He didn't quite smile. Kithral facial range doesn't overlap significantly with human, but something in his posture changed, a slight settling of the lateral organs in a position I'd come to associate with relaxation, and he nodded once. We went back to work. Thelvan came to find me on day 5. I was in the equipment bay doing kit inventory, last full day before the tool cases were logged back into station stores, and my assignment ended. He stood in the doorway for a moment, in a way that reminded me, slightly uncomfortably, of my own position in that same doorway 11 days earlier. Then he came in. "The technical record is going to note the pre-seal anomaly monitoring gap as a systematic issue," he said. "The threshold calibration for Sector B monitoring will be adjusted." "That makes sense," I said. "The notation method, the single-frequency fault mapping. I've asked Suvith to develop a formal technical documentation for it. We'll run a trial adaptation alongside the existing diagnostic protocol in this facility and assess the results." "Good," I said. He was quiet for a moment. Then, "I reviewed your service record in more detail after the broadcast. I kept counting kit inventory. 8 years of field service," he said, "forward operations, bunker systems, combat zone acoustic isolation." A pause. "The context in which you would have developed this technique." "They don't always have parts depots," I said. "No," he said, "I expect not." Another pause. His lateral organs were in the relaxed position, all 8 of them, I noticed, rather than the professional assessment 4, full extended. Whatever this was, it wasn't the orientation. "The designation I assigned you on day 1, he said. "Tool transport, calibration kit management, case handling." "I carried the cases," I said. "That was fine." "It was not," he said, "commensurate with your qualification." I thought about saying several things and said none of them. "I'm recommending to Dressen's office that future auxiliary personnel placement be preceded by a full technical consultation rather than a credential file review," he said. "It won't affect this assignment, obviously, but future ones." "That's a reasonable approach," I said. He nodded once. Then he looked at the tuning fork, which was sitting on the shelf above the kit inventory station in the same place I'd put it after the debrief, not packed away in the tool bag yet, just sitting there, 440 HZ, a slight nick on the handle from the 3rd deployment, the manufacturer's mark worn half off from 8 years of use. "Vibrational folklore," he said, very quietly in the tone of a man quoting himself. "Applied competency at low-frequency ranges," I said. "You weren't entirely wrong." He looked at me for a moment with all 4 pairs of lateral organs fully forward. The full assessment, not the professional courtesy version. "No," he said, "not entirely." He left without further comment. I finished the kit inventory, packed the tool bag, and put the notepad back in my left breast pocket. The tuning fork I left on the shelf. I had a second one. I got my transfer orders that evening. New posting, acoustic isolation review, forward installation, outer reach. The kind of job that doesn't have a lattice diagnostic suite and does have a 3-day transit to the nearest parts depot. My new assignment file read, Structural Acoustics Technician, Grade 3, Human Engineering Core. No auxiliary, no parenthetical. Dressen had updated the file before he signed the orders. I noted it in the notepad, old habit.